Good evening, this is Team 6 and this is for EML 4806 Robot Modeling. This is Project 1 and Project 2 PowerPoint. Project 1 was the slider crank mechanism analysis and animation. This is Aldo Melgarejo, Jose Lopez, and myself, Luis Perez. For Project 1, the problem statement was to analyze the mechanism by dividing the full motion of the input by 1 degree steps. The second part was to analyze the two possible closures of the mechanism. We were given R2, R3, and R4, 20, 35, and 5 inches respectively. The QS, which was off of the second rod, was 17.5 inches. The angle and velocity inputs were theta 2 dot at 3 radians per second and theta 2 double dot at 0 radians per second squared. On closure 1, after we did all the calculations on Excel and by hand to confirm our numbers, it showed that R1 was the greatest length at 54.768 inches at an input angle of 15 degrees. R1, our second closure, our R1 was the shortest length, which was 14.138 inches, and at an input angle of 209 degrees. Here's omega 3 versus theta 2, which is the linear velocity versus theta 2, and you can see how it changes throughout the phase. Here's alpha 3 versus theta 2, which is the linear acceleration versus theta 2 at point 3. And this is position S on our slider crank mechanism, which is the QS off of rod 2, rod 3. This is the direction it takes. Here's Jose Lopez with the mechanism and its applications in real life.
All right, here, this is our slider crank mechanism. Here you can see the slider, R2, SL, R3, and this slider here represented R1. Since the slider mechanism was able to go through different lengths of R1, we needed to make R1 itself also be a slider. For this specific application, we added a blade to S and we changed the angle from 5 degrees to 30 degrees in order for it to be an excavating machine that you could see in agricultural applications where the machine will cut through the ground and make holes for new seeds. Here you can see it moving, and basically in our design, the ground would be like my arm, and it will cut into the ground.
Conclusion: mechanism analysis serves as an important role in robotic design. It is important to know the exact position, direction, motion for each linkage in the system. And for the mechanism to function properly, this data must be calculated.
Line. Our assignment for Project 2 was to synthesize a 4-bar mechanism. We were given three sets of coordinates in which the mechanism had to pass through the positions, and given our A1, A2, A3, B1, B2, and B3s, we were able to calculate an A0 and a B0 position. Once these pole positions were calculated, we were able to determine our link lengths R1, R2, R3, and R4. After determining the link lengths, Grafshoff's rule gave us a type 1 crank rocker mechanism. The positions in which we pass through our points, our first B1 and A1 passes at 0 degrees. At 28 degrees, we pass through position B2 and A2. And at 84 degrees, we pass through the last position of A3, B3. And now Jose Lopez will talk about the mechanism.
Thank you. And now, in this mechanism, this is a 4-bar crank mechanism. As you can see, the first bar is the ground, where these 2 points are lined up. The second bar is the shorter one, which in this special case that we created is the crank for these 2 wheels. And you have the other 2 bars, this one being the longer one. In this specific scenario, we have a situation where a user could manipulate said lever to turn the crank and be able to drive the mechanism through a railroad track. And this is how it works.
In conclusion, our Project 2 was to synthesize a 4-bar mechanism. We determined it was a type 1 crank rocker system, and our mechanism properly operates and passes through the points desired.
This concludes our presentation. I hope you enjoyed watching, and have a nice day.